All right, our last video for 8.1 is going to cover how we can find different coordinates to represent the same coordinate. Now that is the really cool thing about polar coordinates and equations. In rectangular world, if I had 1, 2, there's only one way to figure that out. You go to the right one and then you go up 2 and it gives you that location. We can represent polar coordinates many infinite ways. They're not just locked down to -2 pi/4. So you'll see here in a summary right there, like ways that you can do it. But I feel like this, I'm going to erase this, but this takes up too much brain power for my liking. I am not memorizing that by any means. So it's a cool way to like look over it. But I don't suggest memorizing that box. So what I'm talking about is, okay, if I have -2 and pi/4, we just did that one. So that's this location right here. Well, I can come up with many ways to represent that location. One way is I could do a negative angle. Well, what is that negative angle? That negative angle is -3 pi/4. But because that angle put me right there, I'm going to keep my radius +2. Because if I made it negative, then that would have forced me in this quadrant, and that's not what we want. We want the same location, just different way to represent it. So looking at this, these are different, but they're going to give us the same exact location. So in this problem, it says find 3 other ones. So, okay, another one I could do is I could go around the circle 1 time, or 5, whatever you'd really like, and go that additional angle. Well, that would be 2 pi plus, well, maybe I jumped the gun here, but I'm going to keep going with it. Now this angle from here to here, remember that's going to be 5 pi/4. So if you do, so let me actually back up. I could do 2 5 pi/4. Does that make sense? Because, okay, I'm just going to go to my angle 5 pi/4, which is right here. And then I'm going to go out 2, and I end up at the same spot. The one I was just trying to do is now I went around the circle 1 time, and then the additional 5 pi/4. Well, 2 pi plus that angle, find a common denominator. So you end up getting, right, this thing would become 8 pi/4. Well, 8 plus 5, 13 pi/4. Now, some of us might say, but I want to keep my r negative. You have that option too. So this is where we were located. Okay, well, I could go to, what could I do? I could go around the circle 1 time and then go to that additional, let me get out of that, go to that additional pi/4, right? So then you're right here. So that would be 2 pi plus your pi/4. Find a common denominator. But if I just went to 9 pi/4, that would put me here. I need to end up down here, and so that's why I make my radius negative. Personally, that's how I like to do it. I like to play around with it. We're going to do another example. But, you know, everyone's brain is different. Here is a good old list on how you could figure it out always. So if you want some algebra behind it, if you want to keep your radius the same, then you can just add a period to your theta and you get at the same location, right? Hence, period means that's when it starts to repeat. Now, this is where I think it just gets a little funky. We do this in our head. We don't necessarily do it formally with algebra, but if you want a formal way, you negate your radius and you add pi to it and then a multiple of your periods. So whatever you like to use, you can use that. I am going to stick with this way of visualizing it and, you know, adding 2 pi's or taking away a pi or whatever it would be. So because this is, let me just reiterate this one more time. All of these represent the exact same location. So that's really cool, because now what we're finding out in polar world is to be a function, your input, all of these are going to work as functions, whereas in rectangular world, they wouldn't, because your input would be repeated. And again, I might be going over your head. That becomes really important later in calculus, but just something for you to hopefully realize there is some importance here of why we're finding polar coordinates and equations. Now, because there's all these different ways, and these aren't, we're not limited to these 4. There's like so many out there, infinitely many. How we're going to do it in our book, in our homework, is I'm going to give you restrictions. So then we have to come up with the same answers. So we're given this coordinate 4, 3 pi over 4. So I'm going to give myself that location before I commit to anything. And again, I don't have my pi over 4 lines on these. And then I'm going to go out to 3, 1, 2, or 4. So this is my location, because this angle is 3 pi over 4, and I went out 4 units. 1, 2, 3, 4 here. Now, what I need to do is in A, I want to keep my radius positive. That's what it means when it says r is greater than 0. So I'm going to keep it 4. There's nothing else I can do. But now I want my angle to be bigger than 2 pi, but I don't want to go around the circle twice. So I want to go around the circle once, and then that additional 3 pi over 4. So that's why I'm going to do, if I go around the circle once, I add 2 pi to it. And if you want to be using this, you'll see that's exactly what I did based on this algebra system. You got to find a common denominator. So we end up getting 4 and 11 pi over 4. This meets this restriction. My r is positive, check, and my angle is between 2 pi and 4 pi. Well, now for B, they're saying we want r to be negative because it's less than 0. So I'm going to do negative 4. But now I want my angle to be between 0 and 2 pi. So I'm going to get rid of some of this stuff so it doesn't get too confusing. Okay, I want a negative 4. So hopefully this sits well with you. That means I need to end up at this angle right here, because then that negative 4 would force me up there. So what is this angle? Well, you have options. You can either go here or you go this direction. This lets me know what option to take. I have to go here to here because I don't want a negative angle. My angle is between 0 and 2 pi. So that angle, again, just knowing that unit circle, is going to be 7 pi over 4. All right. Now, I want to, for C, I want to keep my r positive, so it's a positive 4. But now I want my angle to be between -2 pi and 0. So I want my angle to be negative. So I'm going to get rid of some things. So instead of, this is my 3 pi over 4, I want to go ahead and find this angle. And again, just looking at your unit circle, so hopefully this is sitting okay with you, that would end up being -5 pi over 4. So the other way you could have done it is you could have taken away or added 2 pi to it. Okay, so like 3 pi over 4 plus -2 pi, or minus 2 pi, it means the same thing. Well, 3 pi over 4 minus 8 pi over 4. What do you know? We get -5 pi over 4. So you can use this algebra way, but I really like just looking at the unit circle because they will, these questions will end up being on your unit circle. To relate it, let's just relate B to that. So what you would do is you take your original angle, you add pi to it, and that's right, that's what it says. So then my pi, I need a common denominator. And what do you know? I get 7 pi over 4. So use whichever method works best for you.